Well, hi, good morning, and thank you so much for joining me in my shop here. Today is February, I almost said January, February 21st. Still cold outside. Maybe a little bit of snow today, probably not. And hey, it's going to warm up in a couple of days. It's going to reach zero in a couple of days. So, well, I'm pretty energized now that I got over the problem with this tube tester, and I still can't fully understand how reversing the leads on this it's a potentiometer basically, I think, or maybe it's a wire wound potentiometer, how reversing the leads could do anything other than just reverse the operation of the control. I still don't understand that, but nevertheless, having put the leads the proper way, so now 0 is 0 and 50 is 50, the unit seemed to start working properly. So I looked at the schematic. I got an email from someone named Tim who has given me a little bit of help with this, and he explained exactly how that could happen, how you could reverse the leads on this and get into this trouble. But I could not look at the schematic and understand it myself. So moving on though, things are good. We're moving on. Actually, I think I'm going to move back and repeat a couple of the earlier. Those are my cats running like crazy. Here, while I'm talking. See if they come bursting out of that room there. Of course, they won't now, but we'll see. Anyway, I've got something else to show you too. I am testing tubes in the evening. I had a box of tubes I had to go through, which I've been working on. And in there's a couple of some unusual tubes. There they go. This goes on. Well, their day goes up and down, sleeping a lot, and right now they're at the peak. We're at the peak of their activity. It only lasts about 10, maybe 15 minutes. They do stuff like this. They run around like just crazy. Okay, they're just cats, Jim. Come on. No surprises from a cat. Let me show you these weird tubes, and then I'm going to, on my own, redo the alignment calibration processes up to the point where I had trouble, to make sure that what was done earlier is correct. Now these tubes, look at these. Would you even think they are vacuum tubes at first? So this is a Beckman, B-E-C-K-M-A-N, Beckman number 931. It says Beckman Instruments here. This is exactly the same thing here. So I looked up a little bit about these. It's very squarish, kind of like most tubes are, round. Look at this thing. It's got a sharp corner here. Is that what that is? Yeah, I can look right inside. It's glass. This one, it looks like plastic. How can it be plastic? Oh yeah, it's plastic. So maybe they've got a plastic cover on top here. I don't know. They look identical otherwise. I'm sure they're the same tube inside. But I thought those were interesting. They look different from any other tubes I've seen. There you go. Interesting tubes. I have a bunch. Okay, so I'm going to attend to the calibration and get us up back to where we were stuck. Okay, here we go. Step 1, adjust this to say 5 volts using the line adjust. Bring this up. It took me quite a while to get this set up, by the way. So make this as accurate as I can. We got 115 volts coming into the machine. That's pretty accurately 5. Now we want to make sure this is centered. It's not. And that's done with number 9 here. There we go. Let's center that meter. Dead center. Check again. 5. Center. Whoa! Success on step 1. Fantastic. Okay, here we go on step 2. This is supposed to be 2.8 volts. No, it's pretty close, isn't it? Let me look at the front panel, although the meter's hanging. Okay, so we're no longer in the center, but it could be because I tipped it up and now the balance in the meter's changed, so the meter pointer's in a different spot now. 2.8. If I swing the line adjust, does this move? What happened to the 5 volts? So good question here. Now, do we just adjust this to make sure it's the line adjust is centered and assume the 5 was correct? Go back after the 5. Let's see if I can poke it. Number 5 is should be 5 volts here. So it's gone a wee bit high. Now, is that just because the line voltage has gone up in the house? So to make that 5, I'm supposed to make it 5 with the this adjustment here. Now, make sure the meter is centered. Okay, and it's hanging. There it is. And we should have 2.8 here. This doesn't change it. Oh, come on! So I guess some fluctuation just from the line voltage going up and down. Here's the line voltage here. And here. And here. No, this one's not the line voltage, but I think this might go up and down also because of line voltage fluctuations. Well, I don't know if I can make it any better than that. What happened? I leaned over and it went up? Huh? Did I see that right? I leaned over and it went up. Really? That's what did it. Oh, it went down just now. I got a bad clip lead. I got a bad clip lead, I think. How do you like that? I think that would qualify as a bad clip lead. Let's try a different one. The meter's got to go wild there. Nope. What happened to 2.8? I ended up with this control at its maximum. Some strange stuff going on here. 2.5. Wasn't it supposed to be 2.5? Why have I got supposed to be 2.8? Oh my god, I've confused myself here. Let me just peek at the instructions. 2.8. Adjust for 2.8. Can't get anywhere near it. Oh, for crying out loud. No wonder. I don't my whole meter's not connected. I get a laugh out of this kind of stuff. Okay. 1. Okay, that's probably from me adjusting this thing. There we go. There we go. It's really important, whoops, that you actually connect the meter when you're going to make a measurement. Ooh, big jump there. Is that going to be accurate enough? Why am I trying to get this absolutely correct? 2.8. Okay, that's it. Bingo! Step 2 done. Or some number of steps done. Very good. Okay, I've got a 2 kilo ohm resistor there as instructed, and we can probably tip this right up. Okay, now certain settings are required here. Let me just go through them, make sure everything's correct. Okay, controls A through O, bias and filament maximum counterclockwise. Counterclockwise. That doesn't count. Counterclockwise on line. Filament 0, bias 0. Meter switch to line. Meter switch to line. Short switch in test normal position. Short switch. Meter switch, slide switch to normal. Meter slide switch to normal. Bias slide switch to 10 volts. 10 volts. Test switch to off. Test switch to off. Insert line cord, push off, life on, turn it on. Put in a line cord, turn it on, adjust the panel control to center the meter, switch meter to test. Okay, so insert the line cord and turn it on. Turn it on. So turning it on is just that. I don't think I need this meter here. Let's get it out. Adjust line adjust to center scale reading. Okay, center scale reading. Switch meter switch to test. Oh, I'm still in the dim bulbs and everything here. Hold on, back up. Everybody back up. Turn this way down. Flip this up here. Okay, set the line adjust. And the line voltage coming in is 116 volts, so that's normal. Now what happened here? Test switch to off. Line cord push on. Switch meter to test. Rotate test switch to test. That's funny. It's the same thing twice. Rotate test switch to test and note if meter deflects off 0. If it does deflect, try adjusting potentiometer P4. I can't get at it right now. Located on the power supply chassis for practically no deflection when the test switch is rotated to the test position. If the adjustment makes it worse, it may be on the wrong leg and do this rewiring thing if that's the case. So okay, I don't think that's going to be the case. So switch meter to test. Rotate test switch meter switch to test. Meter switch to test. Jimmy, I make mistakes here. Switch meter switch to test. Rotate test switch to test. Okay, see, it's not saying the same thing twice. Does the meter move? Oh, wait a minute, it's way off. What happened there? Whoa, wait a minute. Rotate test switch to test and note if meter deflects off 0. Well, it sure does. Way off. Of course, P4 will be at an extreme setting right now because I was told very early on in instructions to set all those adjustments to an extreme setting. So P4, eh? Okay. Let's see what we can do here. Or I assume everything has gone south again. P4. So P4, I gotta stick a screwdriver in there. Maybe let's see if I can get this guy to go in. He might be too too big. No, I'm in. Okay, we're on P4. What did it say? it said switch meter, switch to test. Rotate test switch to test and note if meter deflects. If it does deflect, try adjusting potentiometer P4 until no deflection. Oh, good luck on this. Let's see what happens. P4. Here we go. Oh yeah, look at that. Going down. Excellent. Okay, so we'll put it like that. And you can see the meter barely. I let go. Okay, success there. Okay, that's fantastic. Where are we now? We're down to GM adjustment. I feel like I missed this one I just did. I feel like I missed it the first time through. GM adjustment. Set up front panel for a 6C4. Okay. I'll do that. Okay, I think I'm ready for the next step. I have the instructions on a computer screen beside me here. So this is a 6C4, I'm sure. This will look to be absolutely sure. 6C4 in. And here we go. It says, set the front panel controls. I've done that. Insert the 6C4. Turn the power on. Oh, okay, turn on the power. Power's on. That a moment. I'll read the next step. Rotate short test switch through all its positions and returning the test switch to the normal position. Short neon light should light only in 1, 3, 4, and 5. Okay, we can do that. 1. It's hard, maybe hard for you to see, but the light has come on. Off, on, off, off. Okay. As expected, totally normal. Rotate the test switch to hold. I'm just going to read these before doing it. Rotate test switch to hold. Rotate meter switch to line. Adjust line adjust. Adjust the line adjust with the test switch and hold. I guess that's to apply voltage to the tube and get currents flowing in the tube. So when you do the line adjust, you've got all currents flowing, I guess. Maximum load. Rotate meter switch to bias slide switch to 10. It's on 10 already. Adjust bias potentiometer from 5 volts. Interesting. You adjust it to 5 volts. During the real test, it's 4.8 volts, but during this calibration procedure, it's 5 volts. Okay, rotate the test switch to hold. Rotate meter switch to line and adjust line adjust control. Meter switch to line and adjust line adjust control. Your center scale. Okay. Rotate meter switch to bias, slide switch to 10, adjust bias to 5. Just flip this to bias, and now 5. Right on the money. Okay. Repeat section C and D above. Okay, so we just go back and make sure the line is still, it's gone a little bit high. I guess they really want a lot of precision in this particular process. Bias, touch low, that's got to be good now. Okay, everything is nice and stable, just the way they want it. Rotate meter switch to test and note reading on 3000 scale. Rotate meter switch to test and note reading on the scale. Get a piece of paper and a pencil here. On the 3000 scale. because we're set to 3000 here. On the 3000 scale, it's exactly 6.7, 0.67, 670 is what it would be. Make sure I'm getting this right. Gotta be. Is there another 3 scale? No, there's only one 3 scale on here. Oh, there's another 3 scale, but that's current for the heater current. 3 scale. It's nice and stable. 670. So I'm going to want to reproduce this value on the as I do the process here. Okay, 670. What does it say next? It says without changing any settings whatsoever, rotate plate shunt switch to D. This changes the instrument to the 6000 scale. Adjust potentiometer P5A on power supply chassis for same reading on 6000 as was seen on 3000. So you rotate this to D, to here. And now on that scale it's going to get a little difficult, but I'm supposed to adjust but P5A for the same reading. Okay, this is a little difficult here. 670 on the 6000 scale. So we would see, so this would be 6, it's about 700, it's a touch more than 700 on there according to my observation. 5A, we would want to bring it down just a wee little bit. Oh, wrong way. So I'm going to get 670, 6. That would be 670 there, I would say, right there. Okay, we're done on that one. Now, adjust potentiometer P5A did that. If the meter, okay, should we repeat G above, except the plate shunt switch is rotated to the 8K range, adjust potentiometer P6 for the same reading as observed in the other. So we go to the 8K range. That's here. Oh my gosh, it's hardly moving the meter up now. I wonder if I'm using a weak tube here and that's causing this, but I don't think so. I don't know. And what are we adjusting now? Don't make a mistake now. P6, same reading. P6. Okay, here's P6. Get my hand in there. 670 on the 8K scale. Oh my gosh, way down here. So it's pretty darn close. How is this done? So this is 1. Oh, watch out. Okay, so this would be 2, 4, 6. You know what? It looks like 670 to me right now. I don't know how I can make it more accurate. Okay, and that's not surprising. I've done this process earlier. That's it for that. Okay, so we've done the calibration of the meter basically, although I don't like working way down here. Good enough for now though. Time for a coffee break without a doubt. Thought I'd share a couple of pictures with you while I'm waiting for my coffee to cool down. That's what it's like with these 2 cats. And that's my wife there. And this is looking out of our front window, so this is my front yard down here. And you can just get an idea how much snow there is out and about. This is a little more, this is the other direction here. So, and that's my driveway down there, and these are our bird feeders, which are quiet at the moment, but get very busy in the afternoon. We get lots of birds here on bird feeders, which our cats love to look at. Oh, okay, try as I may, I still made a mistake. I forgot to remove the 2000 ohm resistor I installed for the earlier test. Now whether it's throwing everything off, subsequently. Here it is here. Not sure, so I'm going to make a quick check of that situation, and then we'll carry. I'm going to remove this, redo the calibration steps just to check them, and then we'll carry on. So after doing the process again, only this time with the resistor removed, I got a reading of 700 here instead of 670. That's almost the same thing. And when I check the different scales here, it's all fine. So a 6C4, I'm not saying this is being tested properly as a 6C4 right now, because we're doing calibration, so but it's close. Anyway, 6C4 is supposed to have a 2200 is the transconductance of a 6C4. And this one's measuring 700 in this tube tester. Didn't I test it in other testers and it tested much better? I'm going to go repeat that. That'll be the last thing for today. I'm going to go repeat this test, or test this tube in another tube tester and see what we get, because I'm pretty sure I got 2200 last time. Let's see. Okay, so here's the test results. Now the other day I did that same tube I just did now, the 6C4, and I got 1600 in the 966 tester. 1600. I got 1800 just now. I just did it now. Why am I different? I don't know. 1400 in the Weston. So these three tests are all kicking up around 1500 to 1800, in that range. A brand new tube should test at 2200 supposedly in the 966 in the start tester. But what I'm actually getting in this tester with the same tube is half that, 700. So there's something still going on here that's not correct. The if I just take a peek, what is the reject point for a 6C4 here? Let me just take a look. Oh, you know what? It's going to be a hassle for me to find out. I think maybe too much of a hassle here. Maybe not. Maybe I would just look here and just dial this down to 6C4. Here we go. 6C4. And also give me a chance to compare the test settings right now, because the bias is set to 5 volts, not to the proper test voltage. You know what? I may have to do this again. 6C4, the proper bias voltage isn't 5, it's 4.8. It's just slightly below. 1300 is the reject point. So you can see the testing at 700. This tube tester is telling me that 6C4 is a garbage tube. Throw it away. That's what it's saying. But it's not true. Could it be the bias? Well, I just can't resist. Let's find out. Turn the thing back on. We'll put the tube back in. Okay. So the bias should be 4.8. So we're on a 10 scale, so obviously 5 is right in the middle. So 4.8 is just a hair below it. I mean, I can't imagine it's going to make that much difference. Okay, first of all, line adjust, right on the money. Here we go with the bias. I will now adjust the bias downwards to 4.8. I mean, it's just, a couple of needle widths. We'll mess around with it when we do the test, and we're going to do the test. Here's the test. So it's still right down there at 700, and I'll vary the bias a bit. I just see it. I mean, look at, there's hardly any change in the position of the meter. If you can see it wiggling there a little bit. So for some reason, this guy's testing half what it should show. It's showing me 700. Is there a multiplier in here? I don't believe so. I don't believe so. Some of these testers, the reading you get off the chart, you have to give a multiplier to it, maybe a 2 or a 3 times what you're reading right off the scale. But it looks like this one's direct reading. You got the scale adjust thing here. Well, we'll just carry on and see where we get to, because I've not completed the calibration process. So maybe something will happen down the road. Maybe. Okay, well, thanks a lot for watching, and tomorrow we'll proceed through the following steps. I think it involves these big 6L6 tubes and really beating the machine up, putting a big honking tube in there, I guess. We'll see ya.